Okay, Mr. Walker back with another video on how to simplify expressions with exponents. Same four questions. What type of problem are we trying to solve? We are trying to simplify an expression where the exponent is 0. How do we know what type of problem it is? There is an expression where you have an exponent that is equal to 0. I've got two examples here. X as an exponent of 2, but y as an exponent of 0. And if we think about what we did in the last video with division, 3 minus 3 is going to be equal to 0, so our x will eventually have an exponent of 0 here. How do we do this? We will use our properties of exponents again. There's a rule, and we'll apply it. How do we check our answer? We will go back and double check our work or arithmetic to make sure we didn't make any mistakes. So, we've answered our 4 questions. Let's jump into it. Simplifying expressions with exponents that are 0. What happens when you divide powers with the same base and get 0 as an exponent? So let's look at this example. I've got a 4 and a 4. Our rule says we subtract. So 4 minus 4 is equal to 0. So let's expand this. 3 to the 4th means I've got 1, 2, 3, 4 3's multiplied on the top, and 1, 2, 3, 4 3's multiplied on the bottom. That's going to be equal to 1 over 1, which is equal to 1. So that's an explanation of how the property works. Same as in all of our previous videos. Let's look at this 2 ways. The arithmetic way, using numbers. If you have a 0 exponent, the value is 1. 3 to the 0 is equal to 1. Algebraically, we'll get rid of the numbers. We'll use variables. A to the 0 is equal to 1 so long as a does not already equal 0. So the simple version of this is if you have a number raised to a power of 0, the answer is 1. If you have a variable raised to a power of 0, the value is 1. Let's look at a couple of examples. I've got negative 8 squared divided by negative 8 squared. Our division rule says we are going to subtract. So I've got negative 8 to the 2 minus 2. 2 minus 2 is 0. Negative 8 to the 0 is equal to 1. That one was pretty simple. Let's look at one that's got a bit more work involved. Here I've got 6b cubed divided by 18b cubed. So I like to break problems into pieces. So let's deal with the 6 and the 18 first, because they don't have an exponent. I can simplify that to 1/3 because there are 3 6's in 18 and 1 6 in 6. So 6 over 18 is equal to 1/3. Now I've got division. B to the 3rd divided by b to the 3rd. So I've got b to the 3 minus 3, which is now equal to 1/3 b to the 0. And we've already said that anything raised to a power of 0 is equal to 1. So this is now 1/3 times 1, which is equal to 1. Now, we can quickly go back and look at our arithmetic. 6 over 18 is 1/3, so we're good there. I've got b to the 3rd divided by b to the 3rd, which is 3 minus 3, check. 3 minus 3 is 0, check. 1/3 times 1 is 1, check. So our math works out, and we feel really good about our answer being... Actually, see, look, I did make a mistake. That's actually kind of cool. Our answer is 1/3, not 1. 1/3 times 1 is 1/3. And there's an example of why we go back and check our work. Let's look at another one. Okay? Let's look at this one. I've got x to the 5th, y to the 6th divided by x to the 5th, y to the 3rd. So let's set up our division, because that's what we'll do first. X to the 5 minus 5, y to the 6 minus 3. 5 minus 5 is 0, so I've got x to the 0, y to the 6 minus 3. 6 minus 3 is 3. We've said anything to the 0 power is 1, y to the 3rd, which means our answer is y to the 3rd. Go back again, check our arithmetic and our math. I've got 5 and 5, 5 minus 5. I've got 6 and 3, 6 minus 3. 5 minus 5 is 0, 6 minus 3 is 3. 0 is a 1, y to the 3rd. I feel good about our answer. And that's how we simplify expressions where we have an exponent of 0. Thanks.